Okay, well, I was reading through the subject of like capacitors. I wanted to make a hopefully quick video about using polarized capacitors, like electrolytics, in an application where it's, like you've got an input to an amplifier, okay, and, you have these coupling capacitors, for the inputs, and, you'll usually see them in the outputs and so forth. You may think, well, that's like an AC application, isn't that illegal? Well, the only thing you got to remember is that it's not illegal, okay, to have an electrolytic capacitor with a varying signal on it. But you want to make sure that it always has DC applied, and he's kind of alluding to that in his little capacitor section of that article on, the Elliott Sound Products articles. This also is on his site. Um, but like I said, like even here, obviously given the polarity, okay, he's got a voltage divider driving this transistor, um, and basically, you can see that, that's actually a relatively high voltage. It's got 4.7K versus 2.2K, so that means the voltage is going to be somewhere in between VE and ground, right? Okay, so because of that, that tells me, basically, he says 12 volts, so basically he's expecting this to be somewhere around 8 volts or so. So basically, his input, I guess he's assuming, is going to be less than that, so that there's always a DC bias voltage on it. So with no signal coming in, this end would have to be less than 8 volts to use the capacitor the way he's got it drawn here. So like if it had 4 volts as its quiescent level, in other words, with no signal, it has a DC 4 volt across it, or even if it just had 0 volts across it, that's fine, because it's not, the polarity's not reversed. It's still positive here and negative here. But you wouldn't want the reverse to be true, because electrolytics in particular, act like a short circuit in reverse, which is actually okay. There are occasions you can get away with, with a capacitor being in short circuit, as long as it's not unlimited. And if you have a big resistor in series with it, you can actually use it in reverse. It may screw up the capacitor over the long term. I don't know, but the fact of the matter is that, it'll just act like a very, very, it literally will conduct power. So you just want to make sure that power is not so much that the damn thing gets hot inside and explodes, or is hot enough to damage it even, to exceed its temperature rating. But it theoretically could. I mean, if you had like a 100K resistor in series with it over 12 volts, it probably wouldn't hurt the capacitor. I don't think. That's, in my opinion. It might. Do your own research. But in theory, it probably wouldn't. In fact, I've seen it when people take, two electrolytic capacitors and put them back to back, like 10 microfarads and back to back with another 10 microfarad, in the other polarity, to make an AC electrolytic capacitor, which supposedly those motor start capacitors and so forth, and the motor run capacitors you see that are clearly electrolytic because their value is too high, it's too many microfarads to be anything else, but they're not polarized, they're for AC. My understanding is they do them that way. They actually have two electrolytics that are back to back like that. So that means, when one is acting like a capacitor, the other is acting like a short circuit, and vice versa. So, when your voltage waveform changes, polarity, well, it works the same in reverse. So, but you're only using really half the capacitor at any one time. But that's my understanding. Again, your mileage may vary. Do your own homework when it comes to that issue. But again, when you're using a capacitor like this, because I used to avoid these like the plague. I mean, even like 10 years ago, I've never even think about using hell, there's a signal involved, but really, you think about it, it's not a big deal to have a varying voltage across it. So let's say this was 4 volts and this is 8 volts, like I said, it probably roughly is. Well, that means you got a 4-volt drop across the thing, so that's a DC voltage across it. But you can still have a signal that 4 volts vary by plus or minus, you know, like 4 volts, so it could go up to 8 volts and as low as 0 volts, for example. And you're getting a varying voltage, but you still always have anywhere from 0 volts across it to, you know, 8 volts across it, right? You know, with an applied signal. So, you know, and that's fine. You know, even, yeah, that's kind of, it turns out to be an AC signal. That's why you put these in here, so you get rid of the DC part, and that's that it's only the signal that's fed through to your amplifier, assuming your capacitor is fully charged, which usually takes a little while when you first apply power to a circuit. Um, you'll see that on Fallstat and some of those simulators. You know, if you do simulations of things like this, you'll see that it may take several minutes of running the simulator before that capacitor actually gets up to its proper voltage. So, but you know, the fact of the matter is, as long as you got a DC signal, it's fine. Now, if you somehow applied a much bigger signal to that, then you might get into trouble because it'll act like a short circuit. And if it's not impedance limited, well, it could literally blow up the capacitor. I mean, I've certainly seen electrolytics explode. You can see videos of that all over the internet, all over YouTube. But at any rate, you know, I just wanted to kind of, you know, touch base on that, you know, that subject, because, you know, that used to kind of confuse me. You know, how the hell are these people getting away with that? Don't they know that's illegal? Well, it's not, you know, but you've got to really take into account what this side of the voltage, you know, this side of the capacitor's voltage is going to be versus this side of the voltage. So, and something that's an unspecified input should always actually come with a voltage warning on it, you know, you would think. Okay, input, but, you know, only input, make sure it's like well below 8 volts. You know, so, you know, because even the signal, that's what I'm saying, if it was 8 volts input and 8 volts output, okay, there's 0 volts across the thing, and then you apply a signal at that point, then it's acting like AC, okay? So that means, you know, when the voltage is lower than 8 volts, you're fine, but when it goes above 8 volts, well, it's a short circuit. So, you know, so there's that. And if it's got enough power to it, it'll damage your capacitor. It may even damage it even if there's not much power. Again, I'm still apprehensive about using capacitors that way, especially if I wanted long-term reliability. But anyway, in theory, you know, you can get away with it. So I just wanted to cover that topic specifically, you know, just like my covering, you know, what ambient temperature means in electronics. I mean, that, you know, that warrants its own long-ass video. But at any rate, you know, cheers.